Hello guys, welcome to Magnetism, force experienced by current carrying conductor in a magnetic field. Now here we have to find the force which is experienced by this conductor right here. Now, in a conductor there are a number of free electrons, and if a current is applied, they all move in a fixed direction. And here none of those electrons actually escape out of the conductors because, well, let's say an electron theoretically escapes the conductor. Well, what now happens is a positive charge is developed on the conductor, and well, the electron being negative charged, the force is attractive, and the conductor attracts the electron back and it goes inside the conductor. And here, if those electrons are put in a magnetic field, well, we know that a charged particle in a magnetic field, well, it experiences a force known as Lorentz force. And each of the electrons, and since electron is, well, obviously charged, they each in itself gets, well, experiences force. That means, and each electron experiences a Lorentz force. And since in the conductor the total number of free electrons remain the same, that means that the force experienced by this current carrying conductor in a magnetic field will be equal to the total number of Lorentz forces experienced by each of those electrons. So that means that the Lorentz force of this conductor will be equals to the total number of electrons into the Lorentz force experienced by each of those electrons. So here, let's find Fe. Well, the Lorentz force experienced by one electron is, well, the magnetic field into charge, which is E, into its velocity, which is the drift velocity, and into sine theta. So sine theta. So we have n dv sine theta. Now let's find what n is, this capital N. So this capital N represents the total number of electrons in this conductor. Now let's say we have n, which is equal to the total number of electrons divided by unit volume. And here this will become n is equals to nv. So here we can write volume as, well, cross-sectional area A into length L, which is NaL. Now we can put this here, so it becomes NaL BeV sine theta. Now we can rearrange this, so it becomes, well, V E N A. I write B here, length here, sine theta. Now VENA, Vena. Well, if you remember in class 11, in the chapter DC, direct current, here current is equals to the drift velocity Vd Dena, or I like to call it Vdena, but here you can write it as the same. This is the drift velocity Vdena, or simply Vena, which is, well, the current. So this is BIL sine theta. So this is the Lorentz force, or simply the force experienced by current carrying conductor in the magnetic field. You have to remember, I think 3 or 2 things. So let's count it. First, you have to remember that the force experienced by the conductor is equal to the, well, the each electron's Lorentz forces summed up. So the total number of Lorentz forces acted upon each of those electrons. So basically this is the first step. Then you have to find out what the Lorentz force of each electron is, which is the second step. Third step, you have to find out what the total number of electrons is in terms of volume. So that is third. And now lastly, you have to use this formula right here. And finally, you get the Lorentz force. So these are the 4 steps that you need to, well, remember and practice. But it is logical, so you can just, interpret this in your mind however you want. And if you learn something new, please like and subscribe. Thank you.